Hi, Algebra 1 students. These notes are on vertex form of a quadratic function. This goes with Module 4, Lesson 16 from your workbooks. So first of all, the big idea here is that we have this vertex form a parentheses x minus h squared plus k. And this allows us to see all the different transformations of the graph of this function compared to x squared. So we say the vertex form of a quadratic function allows us to easily see the transformations of the graph and identify the vertex as well. So if we take a look at this function, then if we take a look at this form, let's start to break it down and think about what is each value, a, h, and k, going to do to our graph. So let's start by looking at the a value. This a is the same a from standard form, right? So we know that this is going to make our graph skinnier or wider or be a reflection. So we're going to kind of list out those possibilities. So we'll have a vertical stretch. We'll have to remember these vocabulary words from when we did transformations in Module 3. So a vertical stretch is going to make your graph narrower, and it will occur if a is greater than 1, so it needs to be some number greater than 1, or it could also be negative, in which case it would be less than negative 1. And then the other thing we say here would be a vertical shrink. And that's going to happen. First of all, that means it's going to make our graph wider. And that happens when a is between 1 and negative 1. So when it's some sort of fraction or decimal, it's not greater than 1. And the last thing that a does, and I kind of didn't leave enough space for this, would be that it also would be a reflection. Over x-axis. And that's going to happen if a is negative. So I'm going to put a is less than 0 there. Okay, so all of these things this is a little bit messy, but all of these things grouped together are the things that a is doing to our graph. All right, now let's think about h. So for h, I'm going to have to kind of highlight it, and I'm going to kind of draw an arrow down here. So here's where we're going to talk about h, which is going to be a horizontal shift. So that's going to be left or right. And in class today, we saw that when you have some positive number in this spot, so you have x plus something, that's actually moving it to the right. And when we have x minus something, that's actually moving it to the left. Okay? And then the last one is k. Kind of like draw an arrow out over here for k. K is going to be our vertical shift. So that is moving our graph up and down. And what we saw, or we didn't quite see in class today, but we saw with the absolute value graph is when you're adding something kind of outside parentheses, that's going to shift it up or down. So a positive k would move it up, a negative k would move it down. And then our last big kind of takeaway from this form is that your vertex will always be the point h comma k, where h, notice this h has a different sign than the h in the formula. So that means you're taking the opposite sign of what you see inside the parentheses and the same sign of what you see outside the parentheses to get your vertex from a vertex form equation. So let's take a look at some examples of that. So when I look at my first set of examples in example 1, it says state the vertex. So the idea is I need to identify my H and my K. So in this case, H, well, remember, I'm doing the opposite sign of what I see. So because I see a -6, that means I should have, that's moving it to the right, to +6 for the X value of the vertex, and then +2 for the Y value of the vertex. So I kept the sign the same for the K, but I switched the sign for the H because I know it moves like the opposite direction. So similarly in B, we have x plus 4 squared minus 3. So if I see a +4, I know that's actually moving it left. So then I should be at -4, -3. Okay, and then the next one doesn't actually look like it's in vertex form because I don't see any parentheses. So the idea would be like, well, if I don't see those parentheses, that's as if I'm doing like x plus 0 squared, right? So you can think that means that the x value of your vertex would be 0, the y value would be the value outside of the parentheses, -3.5. And then for the last one, I don't see any plus k, so we can think about that as being like a +0, which would mean our vertex here would be opposite sign inside the parentheses, so we do +20 and then (0). So that would be, if you're given an equation, it's really not that hard to pull out the vertex if we have vertex form equations. So now for example 2, it says write a quadratic function with the given vertex. So now it's kind of like we're working backwards here, and we're plugging in an h and a k into our vertex form formula. Okay, so the idea would be I should do x minus 2.3 squared. So I switched the sign of what I saw for h, and then for k, I'm just keeping the sign the same. Now, because this is a function, I need to have like y equals. And then I also could put some number in front for a, but it doesn't say what a is, right? So there's more than one correct answer to this. There's more than one graph that will have its vertex at 2.3, -6, because it could have different widths. So like arbitrarily, we could just kind of assign a value. So I'm going to say 2, but we could use any number for a because it doesn't specify. So for the next one, it says 0, 50. So plugging in, that would be x minus 0 squared plus 50. Again, I can put some number out front. I'm going to do -3 this time. Now, what is x minus 0? That's just x. So really, I don't need to write it like x minus 0. I can just write it as an x squared. So now I get y equals -3x squared plus 50. And then for the last one, we have a vertex at -8 as my x value, so I should put in +8 squared minus the y value of -3/4. Y equals in front, and for this one, I'm going to have just a negative sign in front as my a value of -1. So again, if it doesn't specify a, you can put any number out front as long as your vertex will match what is given. So in the last one, in the last section of examples here, it says comparing quadratic functions. So the idea is we want to try to say, like, how will the graphs of these two functions be similar, and how will they be different? Well, the first thing that I notice is that they both have a -2 inside the parentheses and a +1 outside the parentheses. So that's telling us that these two functions have the same vertex, right? So that's something they have in common. And that point is at 2, 1. Okay? But there are some differences when you take a closer look at the a values, right? This has an a value of -1. This has an a value of 3. And those are going to change what's going on with each graph, right? So in f of x, that negative a value is going to mean the graph will be opening down, right? So f of x opens down because there's a reflection over the x-axis, but g of x doesn't have a negative a value. So g of x opens up. And then the last thing I can do is think about how the different a values are affecting the width of the graph. So since G has an a value of 3, we know that should be a vertical stretch. That's going to make it narrower. So what I'm going to write is G of x has a vertical stretch by a factor of 3. But f of x doesn't have any vertical stretch. It's just going to be the normal width similar to x squared. So the idea of comparing the two graphs of two different functions is thinking about how does the a values in each change the graph, and you can also compare the h and k values to get the vertex. So in your workbook, you are doing problem set 16 over the weekend, and it's on page 90, problems 1 through 3. And so you should use these notes to help you complete that problem set. Have a good weekend.